we've learned that authentication proves identity, and then we've learned that authorization gives permissions to access a resource after successful authentication. Now, one way to configure who gets access to what is through credential policies. Whether we're talking about assigning permissions to internal employees within the organization, we might have a credential policy that is related to contractors that do temporary work and require access to resources within the organization. Or it could be a policy that applies not to a user, but rather to a device. So we have people working remotely, perhaps from home or off-site somewhere, and they need to use a VPN tunnel to get into our network or to get into our cloud-based network services. So we can have a credential policy that determines which devices are allowed to do that. We can also have service accounts. A service account you can think of as being a fake user account that we use to assign permissions to a software component. In the Microsoft Azure cloud, that's called a managed identity if it's tied to a resource like a virtual machine, to give the virtual machine permissions. We might also have separate credential policies to determine who has access to what, such as controlling privileged access, so that administrative accounts in Windows or root accounts in Linux have access to items that are not normally allowed access to by regular user accounts. So this is all part of privileged access management, often called PAM, P-A-M. Now, there are a couple of different standard access control schemes that you're going to be tested on the Security Plus exam. Plus, it's good to know for real life situations where we need to assign permissions to meet certain conditions. Attribute-based access control is called ABAC, A-B-A-C. Now, if you think about the name, what it does is it looks at the attributes of a user or a device to determine what permissions they have to a resource. For example, maybe we will look at a user's date of birth to determine if they are old enough to be applying for a driver's license. Or maybe we'll look at the device type. If it's a mobile operating system running the Apple iOS, then we will allow access to Apple-based type of apps for that set of users. That's attribute-based access control. But we've got role-based access control, otherwise called RBAC, R-B-A-C. Now, a role is a collection of related permissions. So imagine that I want someone to be able to read files in the cloud. I might have a role that allows that to happen, and I could add occupants to that role. I could assign it to users or groups of users or perhaps devices so they have those permissions. So you're adding users, for instance, as an occupant of a role, and then they get the permissions that that role allows. You've also got rule-based access control. This is called RBAC too, and it also is RBAC. So don't rely on just RBAC if you get an exam question or if you're reading literature related to this. You want to make sure you read out what it says. Role-based access control, which we've talked about, and our current topic, rule-based access control. So what's the difference exactly? Well, it's not in the acronym, that's for sure. But with rule-based access control, the difference is that we're using what are called conditional access policies. We have a policy with a series of conditions that need to be met before we allow access to a resource. As an example, you have to be signing in, let's say, using MFA, multi-factor authentication. That's one condition that must be met. You have to be using an Apple iOS device. That's a second condition. You have to be signing in from Canada, so using an IP address range known to be allocated in Canada. So if all of those conditions are met, you're into whatever it is we're defining permissions for. That's rule-based access control. Mandatory access control, or MAC, M-A-C. This is what you'll see in some high security environments. What it means is that we've got an operating system like Security Enhanced Linux, SE Linux, and even at the Android level on smartphones, which run a Linux variant, we have SE Android, Security Enhanced Android. What does this do? The whole idea with mandatory access control is that we assign labels or identifiers to resources, like listening network ports or file objects in the file system. And then we configure policies where the operating system determines who has access to those labeled items. So we might say that if you have top secret clearance, then you have access to this subsection of the file system which contains highly sensitive documents. But it's the operating system that's enforcing it, and it's based on assigning labels to resources and also configuring security clearances. Discretionary access control, or DAC, D-A-C. This is probably what we're all familiar with. Have you ever set permissions on a file or a folder, maybe allowing someone to read or write or delete or modify? That's discretionary access control. You, at your discretion, are setting those permissions. Now, the reality is, you're really in the role of a data custodian, aren't you? And you're really just setting those permissions to align with the policy set forth by the data owner. But still, they call it discretionary access control. And then there's physical access control. That's another access control scheme. Let's not get focused just on the digital side of things. Certainly that's important. What about the real world? So controlling access to buildings with locked doors or security guards. Things like access control of vestibules, formerly called man traps, having locks on server room doors, even locks on equipment racks in the server room. We don't want someone that gets access to the server room just to open up racks and pull out drives from the drive array. That's a security risk. Multiple levels of security, always important. So we've seen then how we have to consider the digital-based access control schemes like PKI certificate authentication and allowing access only if you're coming in from a certain type of device. But we've also seen that it's important to consider the physical aspect of access control.